Hello everyone, welcome to my video. First, let me introduce myself. My name is Zwingly Syalommita Laloan with NIM 2410110600010 from the Information Systems Study Program and from the Information Systems A class. So now I will explain about logic in computers. Computers are where logic is the basis of everything. In this video, we will go into the heart of a computer to understand how this device processes information through the principles of logic. Enjoy watching.
Can I call you Rose? 'Cause you're sweet.
Computers are an essential part of our daily lives. Every day, we use them to work, study, communicate, and relax.
Can I call you Rose?
So a computer is an electronic device used to process data into useful information. Computers work on the principle of binary logic, which uses two values, namely 0 and 1, to perform operations. A computer consists of several main components, CPU, central processing unit, RAM, random access memory, or SSD. Let's go inside a computer. Behind the scenes, complex electronic components and circuits work together to process data. Let's go deeper, until we come to one of the most important components, the transistor. This is the transistor, the basic element that allows computers to think and make decisions. A transistor is a tiny switch that can control electric current. It has three terminals: base, collector, and emitter. A transistor can be thought of as a switch that can be turned on or off. This is important because it is the basis of binary operations in computers, a system of zeros and ones, or off and on. From this simple principle, we can build more complex logic using logic gates. Logic gates are the basic building blocks in digital systems that allow computers to make decisions. They are used to process binary electronic signals, which are 1 and 0. First is a NOT gate, also known as an inverting gate, is a logic gate that has only one input, X, and produces one output, Z. The truth table for a simple NOT gate has only two possibilities. If X equals 0, then Z equals 1. If X equals 1, then Z equals 0. Next, the AND gate is one of the basic logic gates that works using two inputs, namely X and Y, and produces one output, Z. In the truth table of the AND gate, there are four possible combinations of input values X and Y. If X equals 1 and Y equals 1, then Z equals 1. If X equals 1 and Y equals 0, then Z equals 0. If X equals 0 and Y equals 1, then Z equals 0. If X equals 0 and Y equals 0, then Z equals 0, which is another type of logic gate, also uses two inputs, X and Y, and produces one output, Z. The truth table for an OR gate shows four possible combinations of input values. If X equals 1 and Y equals 1, then Z equals 1. If X equals 1 and Y equals 0, then Z equals 1. If X equals 0 and Y equals 1, then Z equals 1. If X equals 0 and Y equals 0, then Z equals 0.
Can I call you Rose? 'Cause you're sweet like a flower in bloom. Can I call you Rose? 'Cause your fragrance takes over the room. Darling, I wanna plant you in my heart. Oh, so love can grow. Can I call you Rose?